So the first example, we have magnesium and nitrogen. We need to identify what kind of element is magnesium. Mauricio and Mia, your camera's on, please. What kind of element is magnesium? Is that a metal or a non-metal?
A metal.
Okay, so you have metal combined with, okay, what's this? What's nitrogen? Is a metal or a non-metal?
Non-metal.
Non-metal.
Okay, so according to the rules, what situation is the first one? Here, the one that says metal, non-metal, what rule do we need to follow for this?
The first rule.
The first rule, okay? In the first rule, it says that whenever you have metal plus non-metal, what is going to be produced is a salt. A salt is a combination of metal and non-metal, okay? So you're going to produce salt as a result, okay? So in the combination of the two, you will have magnesium, okay? You will have magnesium, and remember that magnesium has a charge of positive 2, okay? So you have to indicate the charge. And because you are combining with nitrogen, in a salt, what you're going to be using is the nitrogen alone, which is going to be known as nitrite. What is the oxidation number that we use for nitrite?
-2.
Take a look. The one that we use for nitrogen when it's alone is -3. Okay? -3. So go back to the exercise and we write the charge. And you know what we do, dejo de sincronizar. Okay, what do we do with the charges? What do we do with the charges?
You cross them.
I crisscross the charges. Okay, I crisscross the charges and I will have Mg3 N2. And that is the compound that is going to be formed. If I have to name it, it would be magnesium nitride because it is a binary ionic compound. Now, what we do after is we need to check if it's balanced. So you check what you have in the right and what you have in the left. You notice there is no balance. You are missing magnesium. And even though I know that you can do this mentally, just putting the 3 in front of magnesium is going to make it balance. I know it, okay? But in your homework, you need to show me your procedure, everything, okay? This is what makes an exercise valid. This is what validates your procedure, okay? And of course, whatever I see here must be presented in the coefficients. Okay. So remember, balancing procedure involves not just this part of the procedure, but also the answer, which is the coefficient. And that's it. That's how we finish. Okay. Now, take a look to what we have in the example 2. What kind of compound is this? What kind of compound is this? I note in the part 2 I have water. What is sulfur? A metal or non-metal?
Non-metal.
Okay, so this is a non-metal, and oxygen is an oxide, okay? So basically this is a non-metal oxide combined with water, okay? This is how we identify the type of compound that we have. Now tell me, what rule I can follow in the exercise number 2? I have non-metal oxide and I have water. Non-metal because of sulfur and oxide because of the oxygen. What rule is that?
The second rule.
The second rule, it says non-metal oxide plus water produces a ternary acid, and then it says the main versions of the ternary acid. And you might be wondering, Miss, what? I mean, you never taught us about ternary acids. You just told us about binary and polyatomic acids or oxyacids. It says that it's produced a ternary acid, okay? And let me tell you, this is the one that ends in ATE, okay? The one that ends in ATE. So this is a little bit more complex, so I need your full attention on this one. Okay, you know that all acids are combined with hydrogen, and because it is a ternary acid, we're talking about that this is a polyatomic ion, okay? So that means that it is actually an oxyacid. Ternary acid and oxyacid are the same, okay? It's the same. So in oxyacids, I have hydrogen and I have a polyatomic part. This polyatomic part is going to include this, the non-metal oxide, okay? But as an ion. So tell me, what ions do we have that involve sulfur and oxygen? We have only two ions, okay? We have SO3 minus, which is sulfite, and we have SO4, sorry, this is 2 minus, okay? And it's called sulfate. But the rule says that you have to choose the ternary acid with a polyatomic ion that has the main version, which is the one that ends in ATE. That means that you will choose sulfate instead of sulfite. Okay? So, in conclusion, the non-metal oxide, you will see how it's made. Because it's made of sulfur and oxygen, you're going to look for the polyatomic ion that has the two of them. Since I have two polyatomic ions, I have to choose the main version. The main version is the one that ends in ATE. So the combination will be hydrogen, you know it's a H plus ion in an acid, and the SO4 2 minus. So we're going to form the compound. We're going to crisscross the charges different than one, okay? So this process is going to be, I'm gonna put this apart. So this process is going to look like SO3 plus H2O is producing, okay, how is this formula going to be? Where am I going to put that to?
With H.
With H. So I'm going to put this 2 right here. And I have my product already. Then all I have to do is checking if it's balanced. Sulfur, hydrogen, oxygen. And I compare the two sides. I have 1 sulfur in each, 2 hydrogens in each, and 3 plus 1 equals 4 oxygens. And there I have 4 oxygens, which means that this equation is already balanced. So no need to work more than that. Just remember, whenever you have non-metal oxide, okay, combined with water, the product is going to be an acid. And the part that includes the oxygen of the acid is going to be a polyatomic ion. The polyatomic ion that ends in ATE, which that is the main version of the acid, okay? And then this is what is going to be formed. The formation of the acid is very simple. You know this, okay? You just crisscross the charges and voila. Then you check if it's balanced and that's over. Now, what do we have in the third example? What do we have in the third example? What is this? Is this a non-metal oxide or a metal oxide?
Metal oxide.
You have metal oxide and water. Okay, metal oxide and water. Now we need to see what rule applies to this. Okay, metal oxide and water. What rule I need to follow for the exercise number 3?
The
Rule
third
number
rule.
The third rule says metal oxide plus water produces metal hydroxide. So you're going to take the metal. You're going to take the metal. In this case, it is magnesium. You write the charge of magnesium and then hydroxide. You know hydroxide is the ion OH minus. So you will combine it with OH minus. You have to crisscross the charges. And then how is the final product going to be? How is the last product going to be? What am I missing? Where do
The
I put
2
it?
with the H.
Like that.
Yes.
It's missing something. Think about it.
the negative, I think.
The
The negative sign.
Well, the negative sign, because it's a number 1, positive or negative 1, can be totally ignored. But what is missing here, my friends, is the parentheses. Don't miss the parentheses because then you're going to have a different compound instead. Remember, because this is a polyatomic ion, when you crisscross the charge, that charge must multiply all the ion, okay? And to multiply all the ion, you put the parentheses. And now in this part, you have a metal. This is chloride ion, so it's metal chloride plus oxygen. According to the rule, I have to follow
Number 4.
the rule number 4. It says in the product you will have metal chloride. When this class ends, you can click in the link again so I can finish to explain this exercise. Metal chloride. You know chloride is the ion ClO3 and the charge is negative. Okay. So you write the